Hey, in this video lesson, I'm going to teach you about interval notation, and we're going to look at a few applications of it. We're going to look at domain, range, and then analyzing graphs, so increasing, decreasing, and constant intervals. Interval notation is going to be used when we talk about continuous relations. So in a previous video, we talked about discrete relations, and that was where we had like separate points where you could easily see the points. And these are going to be more like graphs of functions, like linear functions, quadratic functions, stuff like that. And I'll talk about that more in a second. But continuous means that there's so many points on the graph that we can't possibly list them out. So instead of listing them out, we use what's called interval notation. And some examples of continuous functions, I already mentioned a few of them: linear, quadratic, absolute value, cubic, all polynomial. There's lots, but those are just a few examples. And when I say parent function is like that function in its simplest form. So the parent function of a linear graph or linear function is y equals x. So you might see the child function, I guess you would call it. It can be anything like 2x, 2x plus 2, 3x, 3x plus 4, 1/2 x plus 5. It can be anything, but the parent function in its simplest form is just x. And that's a linear function, and it's literally just a line. And then the quadratic parent function is x squared. And again, you can add on stuff to that: 3x squared plus 4, 1/2 x squared, anything where x squared is in its simplest form. That's the parent function of a quadratic, and it is a U-shaped graph. And then absolute value is y equals absolute value of x, and that is a V-shaped graph. It can be upside down. Same with quadratic. It can be upside down, but it's still a V-shaped graph. And then the cubic function is x to the third, x cubed. And that is more of like I did a bad drawing, but it's kind of like that. So those are just some examples. And you can see here that if I were to graph this line on a coordinate plane, this would represent an infinite amount of points. And so instead of listing those points, we use interval notation. And I want to give you a little introduction to interval notation. We have a number line here. So we're just talking about x in this situation, x values or x coordinates, and we can still use interval notation. So let's say we solved an inequality, a linear inequality, and we got this solution for that. And let's pretend like we need to write it in interval notation. Now, if you were to graph this, you might see it where you have like a closed circle and a closed circle, and we shade in between. That, whoops, I don't know why that disappeared. Oh, I think because sometimes when you scribble, it erases. That's a flaw. Okay, so sorry about that. You might see that as closed circles, but in college algebra, we view that as brackets. So when you have the equal to under your inequality, or a closed circle, or a solid line, we use brackets. And so we would write this as a bracket on A, whatever A is, it's some number, comma, a bracket on B. The comma means, in this situation, means that all the numbers in between. So we have this interval notation is a sentence. It's a statement for where our solutions are. So we're saying our solutions are in between A and B, where A and B are included in the set. So this statement is just a different representation of that, but it's saying the same thing. X is in between A and B, where A and B are included. So if A and B were 2 and 5, then 2 and 5 would also be solutions to your inequality. Okay, so in the next one, we have X is in between A and B, and we do not have the equal signs there. It's just less than. So you might recognize that as an open circle or a dashed line if we're talking about two variable. But in college algebra, we use a parentheses. So parentheses means that those endpoints are not included in our solution set. So this would mean that all of our solutions are in between A and B, not including A and B. So if those A and B, if they were 2 and 5, then we could go up really close to 2 and 5, but not equal to 2 and 5. So 4.999 or 4.9 or 4.8 or 1.999, but not equal to 2. So if you're working on solving inequalities, you'll probably know what I'm talking about here, but those solutions, when you plug them back in, they'll only come out to be a true statement when you get really close to 2 or really close to 5 or A and B, whatever those are in your situation. In the next one, we just have we have one where we have the equal sign underneath and the other one we don't. So in this situation, we would use a bracket on the A and we would use a parentheses on the B, and our solutions are in between those two values. So we have bracket A to B parentheses. And then the next one, we have that flopped. We have a parentheses on A and a bracket on B. So B is included in the solution set, but A is not. So we could go up really close to A, but not equal to A. And then everything in between there is fair game also. The next one looks a little bit different. We have X is greater than A. Let me write that out because sometimes students get confused on the symbols. That's greater than. When the big mouth is to the right, that's left. Big mouth is to the left, I'm sorry. That's greater than. So this one down here is less than. That means that all of the X values bigger than A are fair game. So you might see this as an open circle like that. Or a dashed line or dotted line, but we would do anything greater than A is fair game. So I don't really have like an end point here. It just goes off into infinity. So you would write that as parentheses A to infinity. So it doesn't end, it keeps going forever. So we just call that infinity. And then the one below it is greater than or equal to. So we use that bracket. And it goes on forever into infinity. X is greater than or equal to A. So it could be A and then anything bigger or equal to A. And then less than B, so we're pointing to the left. I said that confusingly. I said the big mouth is on the left on that first one. I want to go back and amend my statement there. That was kind of confusing. If you notice here, the arrow is pointing to the right. And you notice here, the arrow is pointing to the right. And then here, the arrow is pointing to the left. On the graph, it is pointing to the left. So less than left. That's easier to remember than the way I said it before. Sorry about that. So when we're writing interval notation, you have to start with the smaller number. And on this graph, we have an endpoint here at B, and then that shading goes to the left. So if I were to try to write the smallest number in my interval notation, I don't really have a smallest number because it goes on forever into the what we call negative infinity direction. So we would say negative infinity to B. And something I didn't mention earlier is that anytime you have infinity in interval notation, you always use a parentheses, because you can't ever equal infinity. It's just kind of a concept. It's just saying it's going forever in this direction. So we have on all of these, sorry about that. Go back, rewind, and put those there. It's pointing, the shading is to the left because it's less than into negative infinity. So we start with negative infinity and we end with B as our last basically critical value or last endpoint. And this one is a parentheses because we don't have equals. Next one, we have less than or equal to. So again, it's pointing into the negative infinity direction, and it stops at B, and we do have an equal. So we have negative infinity to B bracket, and that's it. So that's kind of that notation. That's how you rewrite that as interval notation, especially if you're solving inequalities. But we're going to use this for domain, range, and analyzing graphs. So hopefully this will help you with that. We have, in the first example, a circle. And our goal is to use interval notation to write domain, range, and determine it. Or we don't need interval notation to determine if it's a function, but we are going to do for domain and range. Sorry about that. So when you have a graph like this and you're trying to determine the domain and range, the circle is a pretty easy example to start on because it's we can see it. I'm going to use a highlighter here to show you. Actually, I'm going to box out. It's already a circle, but bear with me here because it'll make more sense later. I'm going to box out where our values are. Uh-oh. I didn't go far enough. Expand. There we go. Okay, so the x values domain is x. The possible x values go from, on the x-axis, from -2 to +2. And then these values on the circle correspond to x values, but I can't possibly list all of those x values, all these two. So instead of trying to list all the possible x values that are within that interval, I'm going to write it in interval notation. Now, this is a circle and it's a solid circle. So I'm going to assume equality here, which means I'm going to be using brackets. So it goes from -2 to 2. And I'm going to use brackets here because it's a solid circle. So I'm assuming we can equal those values. So my x values, I'm saying all my x values live here. I can find x values that are associated with the graph within that interval. Then for y, you focus on, or sorry, for range, you focus on the y-axis. My y values, we have y values graphed from -2 to 2. It's a circle, so it's going to be the same radius, so it makes sense. But start with the smaller number, end with the larger number. It is a solid circle, so we're using brackets again. And that's all you have to do. So those are statements, those are mathematical statements that are saying all the range lives within -2 to 2 where those values are included, and same for domain. So I could list any y value within that interval and it would be counted as a value in our range. Now, to determine if it's a function or not, remember for graphs, we can use the vertical line test. I'm going to erase my box here so that it's easier to see. If I were to take a vertical line, a pencil or your hand or a finger or something, and run it across the graph, at any point or location, if it hits 2 points at the same time, it fails the vertical line test. So in the first vertical line I drew, it failed because it's hitting 2 points at once, which means that x repeated and it is not a function. Not a function. It fails the VLT, vertical line test. So if I were to break that down a little bit more, when I said that it hits 2 points at once, which means x repeats, that means that if I were to write out those 2 points We'll use something that's a little easier. We'll use this one. Hits 2 points at once. If I were to write out these 2 points, that would be 0, 2, and 0, -2, which means that X repeats, it fails the vertical line test, and it is not a function. Okay, let's try this next one here. We've got a line. On one end, we have an open circle, and on the other end, we have a closed circle. So that's going to play into our interval notation. I'm going to draw a little box around where I have graph. And that's going to kind of help me see the possible X's and the possible Y's for domain and range. So on the domain, we're looking for possible X values, which means I'm focusing on the X axis. So I have X values graphed from here, there's an open circle, to here, there's a closed circle. And the X values associated with those points. So this point is -4, -6, and this point is 3, -3, if I were to write it as a point. And the X values associated with those 2 points are -4 and 3. Remember, we start with the smaller number first. Then I need to decide, am I using a parentheses or a bracket? Let me erase this so we can see. Here we go. On -4, I have an open circle, which means does not equal. So we're going to use a parentheses. On 3, I have a closed circle. So it means does equal. And that's going to be a bracket. And that's all you have to do. So this sentence means that all the X values live in between -4 and 3, where 3 is included. So I can go to this graph and I can look at X values all along here. And there's going to be X values that exist all along there. Now for range, we look at the Y-axis. So I want you to pause it, try the range, and come back. I noticed a little mistake on mine. Very sorry. That is a -5, not a -6. I'd drawn through it, so I couldn't see it. So sorry about that. Anyway, yeah. Change it to a -5. Sorry about that. So the lowest possible Y value is -5. The highest possible Y value is -3. And then at -5, we have an open circle. And at -3, we have a closed circle. And that's all. That's all you have to do. And then for to determine if it's a function or not, if we do the vertical line test, erase this so it doesn't confuse us. It's already confused me a little bit. If we take a vertical line and run it through, we hit 1 point everywhere. So this is a function. That's it. That's all it wanted. Okay, next one. This is really cool. We've got a little curvy thing here, a little wave. So I want you to pause it, find the domain, range, and determine if it's a function, and come back and check your work. If we were to draw a box around, I'm going to confuse myself here because I cover up my points, but for the sake of viewing it, I need to draw that down a little bit. Here we go. Okay. The possible X values for domain goes from -3 to 1. That's where our X values live, -3 to 1. And then at -3, we have an open circle, so that's parentheses. And then at 1, we have a closed circle, so that's bracket. Then the Y values start with the smaller number, start at -4, and end at 0, with a bracket on -4 and a parentheses at 0. I remember. And remember that you can write these as points. So this point was -3, 0, and this point was 1, -4, and that can kind of help you find those values. There's one in the homework where, hold on, I'll draw it. There's one in the homework that looks like this kind of, and in my notes, we focus so much on that closed circle, open circle that students are tempted to look at that only. But I want to point something out here really quick. If we were to focus on range, the Y values actually go from here to here. So we don't stop here just because we have an open circle there. We are going to keep going all the way up to the top of the graph for range. And then for domain, we are focusing on those. So just be careful with that. I have something up here that I've kind of paused on because I think I might need to change my answer. When we were looking at range, the Y values stop here. I'm trying to remember, we do have an open circle here, but we have a solid line here. So I might need to amend that. For the sake of not being confusing, let's change this to a closed circle and change those. Sorry, guys. You're not going to come across one like that in your homework or anything. So that's why I just changed it to make it easier as far as lessons go. Sorry about that. Just change that to a closed circle, change those to brackets, and you're good to go. So that makes it easier. All right, moving on. But again, don't forget this. We aren't necessarily stating where these points are. We're stating how high the graph goes for range. Moving on. We are doing, again, domain and range and determine if it is a function. Now this graph, it looks kind of funny. Basically, there is what we call discontinuity. So I have graph here and I have graph here, and there's this break in the graph right here. And that break in the graph it's like skipped over. And so I wanted to cover this because if you are taking college algebra or something, then you're definitely going to see that. And I want you to know how to write that in interval notation. So I'm not going to ask you to pause it and try it by yourself because it's a little bit different. So for domain, we're looking at possible x values. And if we focus on the x-axis here, and I do also want to point out that this keeps going forever, this keeps going forever, that keeps going, that keeps going. So there aren't arrows there, but that I grabbed this graph from a calculator and it does keep going. So if I'm focusing on the x values, I have x values all here. And then there's this kind of break in the graph, and then x values all here. So that looks like this points into negative infinity, this points into positive infinity. It goes all the way up to -4, and it looks like, it's hard to tell, but you can kind of see here, this green line gets up really, 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 really close to -4, but never touches it. So I need to say that in my interval notation. I need to say it goes up really close to -4, but never touches it. And how you're going to do that is with a union of sets. So I'm going to write this as it goes from negative infinity to -4, but it doesn't equal -4 because it never touches -4. But there's still more graph. And so how you say that is there's a break here, but there's still more graph. We call it a union. So it means and, or actually union means or there's some more values over here and they go from -4 to positive infinity. And I have a parentheses on -4 because again, on this side, it goes up really, really, really close to -4, but doesn't touch it. So I need to tell whoever's reading this that it's up really close. So parentheses -4, and then it keeps going into infinity forever. Later, you'll see, like if I have a number line here, and -4 is kind of that place where we're having discontinuity. We call this an asymptote. I'm not cussing. It's called an asymptote, and it means there's a break in the graph. There's a place of discontinuity, a place where the function is undefined. And so that union is just telling us that's where that is. So we have graph all here and all here, but not equal to -4. So that was kind of in depth, but I promise you it'll help you in the future. So that's why I wanted to cover it. And then for range, purple again, range, we're focusing on the y values. And it looks like there's graph here and graph here, and there's this break right here, this jump in the graph. So again, if we're focusing on the y-axis, this goes to positive infinity, this goes to negative infinity. It looks like there's a break here at 0. So kind of like what I drew before with the number line for x, we've got this discontinuity at 0. We call that a horizontal asymptote. So the first one was a vertical asymptote. This one's a horizontal because we're talking about y. Again, that's not the point of this lesson, but you will definitely see it in the future if you go on in algebra. So I just wanted to point that out. So I've got graph from negative infinity to 0. There's a break, and then 0 to infinity. And we write that as negative infinity to 0, there's a break, and then 0 to infinity. So that's as hard as it'll get for interval notation for domain and range, but I wanted to make sure and cover that in the video so that if you come across it, you know what to do. And then is this a function? If we do the vertical line test, we're good, we're good. You might think here, oh, it repeats, but remember, it doesn't equal -4. So we're good as far as x there. So yes, this is a function. The last thing we're going to look at for interval notation in this lesson is analyzing graphs. So finding the intervals where graphs are increasing, decreasing, or constant. So when you're looking at a graph of a function, you trace the graph, or I do. I trace the graph with my finger from left to right, just like you would read a book. So if you take your finger and you start on the left side of the graph and you trace the graph, if the function is going up, the function is increasing on that interval. If the function is going down, then it is decreasing. And if it isn't going up or down, we call that constant. And we're going to use interval notation to describe where that's happening. And we are referring to x when we talk about where that's happening. So it is the x values. Focus on the x values for interval notation. So I have this graph here. I just have one example. And if I take my finger, I'm going to use my laser because I can't anyway. And I start at the left. I'm going down, 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 constant, up, 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 down, 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 down. So if you think of it like a car or a marble or something like that, if you were to place the marble right here, it's going to be rolling down. It's going to be constant for a while, be going up, and then it'd be going down. So that's kind of what you're doing there. And then if it helps, you can locate those values where it changes. So it changes here, goes up, changes here, and then it stops here. So these are critical values. These are the points that we're really going to be focusing on for our interval notation. So since it was going down, it was decreasing, constant, increasing. There's kind of there's a weird little notch there, but it's still increasing, so it's okay. And then it's decreasing here. So we would say the graph is increasing from, we're focusing on the X values. It starts here and it ends here. And those X values, I marked them out so I can't tell, are 2 to 4. And we're going to use parentheses here because even though it's a solid line, since I'm going to be using these values in several different intervals, I'm just going to use a parentheses. And then it is constant from here to here. And that is, again, I marked out my number. There we go. 1 to 2 X values. And then it's decreasing. I believe this, yeah, this graph is, it's finite, it stops. So, like in the previous value where I had, not value, example where I had this one and it keeps going forever, this one it stops. So it's decreasing from 0 to 1. And then there's another interval where it's decreasing. So I'm going to use the union to show that. And that is 4 to 6. So this was decreasing, constant, increasing, decreasing, if that helps. I don't know. It's kind of messy. So that's how you would write that. Again, if there's two intervals where there's decreasing or increasing or something like that, you just use the union to show that. And you use parentheses for these because we're using the values twice. But that is how you would do that. So I hope this helps. If you have any questions, please let me know. I'd be happy to help you out. And I'll see you in the next one.